Welcome to my second video on MATLAB projects. I'm going to be talking about Git today, or generally source control integration in general. But if you missed the first video, there's a link here in the screen, so feel free to go and have a look at it. So in the meantime, let's just jump right in. I'm going to start from the previous blank project that I started off in my previous video, and it's actually pretty easy to add source control. There's a big magic button up here in the project section of the ribbon that says add source control. We bring that up and click, it's just confirming that we have no source control at this stage. Then we click to add project. The default lines that we have is Git subversion or command line subversion. Honestly, most of my customers I'm working with these days are just using Git. I haven't had a subversion conversation for a few years. We just click convert and it does its thing. We now open back up the project, checking all the messages, it's all looking good. Now, as we can see here, nothing much has changed, but we've got a new tab up here saying an awful lot of stuff has been modified. So this is, the modified tab is where equivalent to sort of doing a git status to see what's changed on the file or on the file system or not. I always like to do a commit at this stage just to create a clean commit. And we can see our modifieds drop back to 2, or drop back to 0, and we only have the two files, the git attributes and the git ignore. Let's have a quick look at both of these. Just going to pull them up and have a look. As you can see in the git attributes, open both of these up. So git attributes is pre-processed by MATLAB with all the standard files that we see, whether they're binaries, Simulink binaries, MATLAB binaries, whatever, so that we can use them with all the additional functionality that MATLAB layers over the top of Git, so that MATLAB can merge MATLAB-aware binary files. So we can dive in on them. Similarly with git ignore, we ask to ignore all the standard generated files, all the cache files, the stuff that you don't want to pollute your Git repository with. From there, the project works quite as normal. What we can do is we can, let's just quickly add a new live script. My test script. And you can see when I added it in that project window, it automatically the project automatically added it into Git for me. And we can see its Git status is coming up as new and uncommitted. Let's just quickly put some information in there. And there we have just a basic live script plotting a sine wave. I'm just going to close down that live editor. We can see it's changed. So we can see our modifications, it's come up. We can see all this resources folder making changes as well. The resources is where MATLAB internally in the project keeps its catalog files. Generally, you don't need to worry about this. In fact, you should never need to edit these files by hand. But for consistency, it's just kept inside Git as well. Okay, let's commit that now. And click submit. Okay, now what I'm going to do, I'm going to quickly just come in and make a change to this. Let's plot the cosine instead of the sine and execute that. Looks good, as we would expect. Now, if we look outside, if we look at that, that's a binary encapsulated zip file. It's Git doesn't, an external Git client won't know how to do a diff or a merge on that. But if you do use the Git inside MATLAB, what we have is we have additional layering on top of the Git source control that lets us do binary aware merges. So down here in the source control, I've got revert, that's not what I'm interested in. But I can go back to compare to my immediate ancestors, and it's going to pull up. It just takes a sec. As usual, it comes up on the other screen. And it's looking inside that to see, okay, this is my head version that I'm working on. We can see it's changed to cosine from sine. So we can do that as a comparison and merge, which is very handy when merging branches. So let me just commit that. So that's very handy to make merges. But then how do we make a branch? Well, we have all the standard Git functionality you would expect. Push, pull, fetch, branch, adding in remotes, stash for making local stashes if you need to just quickly pull some down. But what I wanted to show you now is how to branch. Branching is pretty easy. We click on the branch button and we can have a look at the branches we all have in our project already. We just have all in main as we would expect. We haven't created any branches, so we're not expecting to see any, but hidden down the bottom here is branch and tag creation. So if I want to create a new branch, I'm branching off at this commit, and we can create a dev branch from there and move over to it. So we can see at this stage, I have my dev and my main branch. I haven't actually checked out the dev branch at this stage. So what I have to do is I go into my branches, click dev, and switch, and I'm now onto my dev. They're both at the same head, so there's no differences with it, but that's how you do with branches. Similarly with tags, if we wish to create a version tag, we can create the version tag from that source, version 0.0.1, or whatever syntax you are using for your tags. And when you are pushing out to a remote or pulling from a remote, you can do the same thing. So that's the basis of Git. It's all the basic Git functionality you would expect built in, but additionally we've put in layers over the top of Git, some binary aware diffs and merges, so you can look inside otherwise MATLAB binary files. Okay, so that's starting a project from clean. What if I've already got a project open? Well, it actually works pretty much the same. Here's the project I used in the first video, and as we can see, it works exactly the same. The only difference I'd like to point out at this stage is I have a lot more branches, I have a lot more commits in place, and we can see I've had to undertake some merges. I've had to do a merge in at this stage to move to my release 0.3. And that merge has been undertaken using I can have a look at the differences, and it's used those binary merges for it. So it would be as you would expect for all those standard kits on a more complex project. The final thing I'd like to show with Git is if we're starting from a clean project, it's fun, right? If we're starting from an existing project, all good. But a lot of times you'll actually just be given something that looks like this. You'll be given a URL to a project in a Git environment, and you need to pull that down to your local machine. Fortunately, that's really easy to do. So let me just show you how to do that. Let me copy that. Now what we do is we set up the folder that it's going to do. In this case, I'm going to put it into a project called from GitLab, and we go up to New Project from Git. It opens up a dialog. We pop in the remote URL. I'm using an SSH. I'm using an SSH protocol in this case. I'll talk about that in a future video, but works the same with HTTPS. You just need to have your username and password. We're going to pull it into the folder that we're in now. So let's just select the folder we're in. And what this will do is this will go out and pull that project down from the Git repository, open up the MATLAB project that's inside it, and start it up for us. So as you can see here, I've got a source. This is a toolbox I use. For my personal daily use on MATLAB. But again, I'll talk about that in a future video. But that's the basis of Git. It all boils down to using MATLAB Projects, adding your project to source control, and then once you've added the source control, all the standard Git functionality that you would expect appears up on this source control tab in the ribbon. So stay tuned for the next video where I'm going to be talking about a standard folder structure that I use on my day-to-day basis with my projects. See you soon.